Okay, today's video is going to cover the last bit of section 3.3. We're not going to be learning any new rules, but today is really going to focus on applications of some of the problems we've been doing. So instead of just strict kind of mechanical problems figuring out derivatives, we're going to be looking at some applications and ways we would use these derivatives. So the first problem, we have a function y equals x to the fourth minus 2x squared plus 2. And what the question is asking us is to find out if that curve has any horizontal tangents, and if so, we need to figure out where. So the first thing we have to do is really figuring out what are they asking and how do we get that information. So if I read this problem, I know I'm focusing on where horizontal tangents might be. Okay? So now, if I think about it, right, a horizontal tangent, if it's horizontal, it means the slope of the tangent has to be equal to 0. So horizontal is telling me that that slope has to be 0. But now, if I take that one step further, the slope we know is just the slope of the tangent, which is also the derivative. And so what I'm really trying to find out is where is that derivative equal to 0? If I can do that, then I know where it has horizontal tangents. So the first thing I'm going to do is find the derivative of my function, and this is a nice, easy power rule problem. So I'm going to differentiate, and I get 4x cubed minus 4x. And then I'm going to set that equal to 0 and solve. And if I can solve that, then I know where those tangents are. So to make this a little simpler, I'm going to factor out my GCF of 4x. And that means then I have an x squared and minus 1 equals 0. So then I know 4x equals 0 and x squared minus 1 is equal to 0, or x squared is equal to 1. So I know this is going to happen where x equals 0 and where x equals positive or negative 1. So I can say the slope of the tangent is equal to 0 at x equals negative 1, 0, and 1. So that's where my horizontal tangents occur. Okay, the next problem is getting after the same thing, but this is going to be a calculator problem. So I'm going to make a note of that here. Okay, and so it's telling us, if I look at the graph of this function here, so I'm going to go ahead and pull that up. So 0.2 times x to the fourth minus. Okay, if I pull up this graph, I can see, right, I'm looking at 3 horizontal tangents, right, places where that tangent line would have a slope of 0. And I know that's happening wherever my min or max values are happening. So down here, I have a horizontal tangent. Up here, I'll have a horizontal tangent. And then, whoops, back down here is another horizontal tangent. And so this time, we're going to use our calculator to help figure out where those occur. Again, horizontal tangent is just asking where is that derivative equal to 0. So what I'm going to do is, again, I'm just going to find my derivative, y prime. I'm going to use my power rule to differentiate this function. And now, since this is a calculator problem, I'm going to put that into my calculator and graph it, and we'll use our calculator to find out where that's equal to 0. Because that's ultimately what I need to know. Where is that equal to 0? So now if I look at my calculator, now I'm no longer looking at the graph of the function, but I'm looking at the graph of its derivative. And so I'm going to find where the derivative is equal to 0. And I'm going to use my calculator to find those zeros. So I'm going to go to the left of my first 0, hit enter, and then move to the right of that point, hit enter. Okay, and that gives me my first 0 is happening at negative 1.862. And again, because the AP test always rounds to the thousandths, that's what I will typically do unless we ask you to round to a specific place. And I'm just going to do the same thing. Second calc, I'm going to find my zeros using my calculator for my other two zeros. Okay, and my second 0 is 0.948. And I would recommend if you're watching this, make sure you can get these same values on your calculator so we catch any issues early. And last, we'll get our last 0 here. At 3.539. Okay, so it's just a way of doing the same thing as the first problem, but using our calculator to find the zeros of my derivative. Okay, so the next problem, this is one of my favorite types of problems, and this I'd say you could definitely encounter on the multiple choice portion of the AP test. And so we're given a bunch of initial conditions. So I have a function that looks like u and v. I know that when my independent variable is 2, u of 2 is 7. The derivative of u at 2 is negative 5. And then I'm given some information about v as well. And so I need to find y prime of 2 for each of these 4 cases. And so what we're going to be doing here is really using our product and quotient rules. So I know, first of all, if I'm going to find this, I need to find out what y prime is for each of these 3 cases. So my first one, if I want to find y prime, I can tell that y is the product of u and v. So if I want to differentiate y, I need to use my product rule. So I'm going to take my first function, u, times the derivative of v, and then I'm going to add my function v times the derivative of u. That's just applying our product rule. So now I'm going to find these values at the value of 2. So if I want to find y prime of 2, I know that's equal to u of 2 times v prime of 2 plus v of 2 times u prime of 2. And then I just use the information that was given to me at the top to fill in these values. So u of 2 is 7, v prime of 2 is 3, so I have 7 times 3, plus v of 2 is 2, and u prime of 2 is negative 5. So now I can simplify, and I get 21 minus 10, which is equal to 11. Okay, so the other two are going to work in much the same way. The only difference is now we're going to be using quotient rule instead of our product rule. So again, the first thing I'm going to do is just differentiate this. So y prime I know is low, d high, derivative of my numerator, minus high, d low, all over my low squared. So now I'm going to actually evaluate this at 2. So if I want y prime of 2, I need v of 2 times u prime of 2 minus u of 2 times v prime of 2 all over v of 2 quantity squared. And so now we can substitute and then simplify. So I have 2 times negative 5 minus 7 times 3 all over v of 2 is 2 squared. So I get negative 10 minus 21 all over 4. It's negative 31 over 4. Okay. And so we'll leave off C. It's going to be the same idea as part B. It's just reversed. So we might look at that one tomorrow at the start of class, but we'll leave it off for now. So the next couple of questions are questions you have absolutely seen before. We've worked with finding the equation of the tangent line to a curve before. The only difference is that now to find that slope of the tangent, we have to use our quotient rule to find that derivative. So again, if I want an equation for the line tangent to the curve, I need the slope of that tangent, which we know we're going to get from the derivative. And we need a point. And that's already been given to us at 1, 2. So the first thing we need to do is find this derivative. And again, we're going to use our quotient rule to do that. So my quotient rule, I take my low, 2x, times the derivative of my numerator, which is 2x, minus my numerator, my high, times the derivative of the low, all over low squared. And so I'm going to simplify this a bit and get 4x squared minus 2x squared minus 6 all over 4x squared. And so I get 2x squared minus 6 over 4x squared. And so now, since I'm at the point 1, 2, I know my x value is 1. So to get the slope of the tangent, I'm just going to substitute 1 for x. So I have 2 times 1 squared minus 6 all over 4 times 1 squared. So 2 minus 6 is negative 4 over 4, and I know my slope is a negative 1. So I know the slope of my tangent is negative 1. My point is 1, 2. So my equation becomes y minus 2 equals negative 1 times x minus 1. And there is our equation. Okay, number 5 is the same type of problem. We actually have quite an easier function with number 5, and the only difference is we haven't been explicitly given the point. We've been given the x value of that point, and we just have to find the y. So our point, right, we're going to plug in negative 3 for x to find our y value. So f of negative 3 is negative 3 squared plus 2 times negative 3 plus 1. So I get 9 minus 6 plus 1, which is going to be 4. So I know my point is negative 3, comma 4. And now again, we're going to find our tangent, or find the slope of our tangent, by finding our derivative. So this is a very clear power rule. Our derivative is 2x plus 2. And so at x equals negative 3, my f prime of negative 3 is just 2 times negative 3 plus 2, or negative 4. And I know that derivative again is the slope of our tangent. So now I have a slope and a point, and again we're just going to put that into point-slope form. Y minus 4 equals negative 4 times x plus 3. Okay, so the last application that we're going to look at, we've been focusing a lot on equation of tangent lines. And so now we're going to kind of take these ideas a little, but apply them more to rates of change. So for number 7, it says, suppose that the amount of water in a holding tank at t minutes is given by the function v of t equals 2t squared minus 16t plus 35. Okay, and then we have to answer a bunch of questions based on that function. And we're going to be sure to justify our answers. So the first question asks, is the volume of water in the tank increasing or decreasing at t equals 1 minute? And so the first thing that we need to realize is that when it's asking if the volume water is increasing or decreasing, what it's really asking about is what is the instantaneous rate of change. Right? And I know it's instantaneous because it's asking for that change at a particular point in time. So it wants to know how that volume is changing at a point in time, which is our instantaneous rate of change, which again, we also know is the derivative at time t equals 1 minute. So if I can find the derivative at time t equals 1, then I can tell how that's changing. And luckily, this is a pretty straightforward problem to differentiate. So I'm going to find v prime of t as my derivative. And so we get 4t minus 16. And now I said I want to know how I'm changing at time t equals 1 minute. So I want to know what's v prime of 1. And so I can plug that in, and I find out that it's negative 12. And we don't have units here, so I don't need to worry about that just now. So now the question is, if my instantaneous rate of change is negative, right, we were asked if it's increasing or decreasing. And now because my rate of change is negative, I can say that the volume of water in the tank is decreasing at time t equals 1 minute because the instantaneous rate of change is negative. So I can say because v prime of 1, or the instantaneous rate of change, let's see, can you see that? Yeah, instantaneous rate of change is negative. So since the value of my derivative is negative, I know that the volume is decreasing at that point in time. Okay, so part B is the same question, but now we're just looking at it at a different point in time. We're looking at time t equals 5 minutes. So in this case, right, I'm still asking if the volume is increasing or decreasing. I still want to know about how my volume is changing, so we're looking at the same derivative. V prime of t equals 4t, minus 16, and so now I want to evaluate v prime of 5. Which this time gives me a positive value of 4. So now we can say that the volume is increasing and we want to be sure that it's increasing at time t equals 5 minutes because, and I'm going to state it a different way, I'm going to say because v prime of 5 is greater than 0. We're still saying the same thing, that instantaneous rate of change at time t equals 5 is positive or greater than 0. Okay, so now part C wants to know, is the volume of the water in the tank changing faster at t equals 1 minute or t equals 5 minutes? So I'm not concerned anymore about whether it's increasing or decreasing. I just want to know when the change is faster. And so if I compare my two values, right, here it's decreasing at a rate of 12. Here it's increasing at a rate of 4, I can tell that a decrease at a rate of 12 is going to be faster than an increase at a rate of 4. So really what I'm doing is I'm comparing the absolute value of those rates. Because I don't care if it's increasing or decreasing, I just want to know which one is greater. And so since the absolute value of negative 12 is going to be greater than that absolute value of 4, we're going to say that the volume of water in the tank is changing faster at time t equals 1 minute. Okay, and so the last problem, part D, wants to know, is the volume of water in the tank ever not changing? So this not changing implies to me that the instantaneous rate of change is equal to 0, right? If it's not changing, then that rate of change has to be equal to 0. And again, for us, that instantaneous rate of change is just the derivative. So we're looking for where the derivative is equal to 0. So again, we already have our derivative function. We know that v prime of t is equal to 4t minus 16. And I want to know, is there a time when that's equal to 0? So we can solve this equation for t, and we get that t equals 4. So now we can say that the volume of water in the tank is not changing at time t equals 4. And I'm going to put minutes here because that's the unit we've been using. Because v prime of 4 is equal to 0. So in other words, that instantaneous rate of change at time t equals 4 is equal to 0. So that's it for today. We'll be practicing with some of these applications, and then we'll be moving on to review for your summative quiz over these first 3 sections on Friday.